Welcome back to the channel. This video is on particulate matter, or PM. We're going to look at the effect of PM in the atmosphere chemically, how it forms, its sources, and how it is deposited back on the Earth's surface, and the effect on the environment. This is the Earth Science Classroom. Particulate matter is a word that comes from the Latin meaning small or tiny particles. So it is PM for short, and it's a microscopic particle of either solid or liquid composition. Now, in terms of microscopic, the naked eye can see generally down to 0.1 millimeters or 100 micrometers in size. Anything smaller than that, it will be very hard to detect with a naked eye. Now, then you use a microscope to see in more detail, but these particles are tiny and they have mass and they're suspended within the atmosphere, so mainly the troposphere we'll discuss in this video, but also in the stratosphere. Now, both particulate matter and aerosols play a major role in both the stratosphere and the troposphere, as we'll discuss in this video. And this term is generally used in conjunction with atmospheric pollution, atmospheric science, atmospheric chemistry, because of the adverse effects that this tiny particle has in large concentrations on the chemistry and the pollution and the effect on the environment, both vegetation, animals, and humans. Now, in terms of aerosol, which we'll discuss also in this video, an aerosol is the gas mixture that contains those tiny particles of solids or liquids. So the PM, or particulate matter, is contained within this gas mixture that we call an aerosol. So particulate matter is the microscopic particles of solid and liquid, and aerosols are the gaseous mixture that contain any particulate matter. So they derive or reside in the atmosphere, mostly a troposphere and stratosphere, and how they get there is through two main ways or avenues or processes. The first process is from the Earth's surface, either from the oceanic or terrestrial landscapes, and this is called bulk to particle conversion, or BPC, which is a type of primary particulate matter, which means directly into the atmosphere from a certain source. Now, bulk means a large amount of either solid or liquid, let's say soil or rock, or a landscape like a desert, which produces dust and sand particles, and the conversion of that into single particles or particulate matter that go into the atmosphere and are suspended based on their density and mass and the ability for wind to then keep them suspended in the atmosphere. And also, the second way of getting particulates and aerosols into the atmosphere is through a secondary process called GPC, or gas to particle conversion, which means that you have a gas that's going to condense and nucleate and create a solid mass or liquid mass from that gas mixture or gas amount, and this is secondary as a chemical reaction, and this can also produce particulate matter in the atmosphere. Then we have the transportation of this particulate matter and aerosols within the atmosphere through weather patterns, through wind patterns, and these can stay in the atmosphere for a matter of minutes, hours, and days based on the weather conditions, the climatic conditions, the location, and strength and turbulence of the wind. Now, once the particulate matter and aerosols are in the atmosphere, they are either used in cloud formation as CCN, as cloud condensation nuclei, or they are transported and then deposited or removed out of the atmosphere through a process called deposition, which occurs in two ways: wet deposition and dry deposition. Particulate matter in the atmosphere derives from both primary and secondary processes. Primary is direct from a source, and secondary is the source, and then there's chemical reactions that occur within the atmosphere, mostly the troposphere and stratosphere, to create particulate matter through two processes of nucleation and condensation, turning that gaseous aerosol into a solid or liquid particle. Now, in terms of the sources of particulate matter, we're looking at the primary particulate matter, the direct source, and we have natural and also anthropogenic sources. The natural sources include such things as volcanic outgassing and tephra, ocean spray, the continental terrains like the soil, the dust, or silicate particles, soils that are dried out and can be broken down by weather and erosion and then released as suspended particles of minerals, going back to silicate particles. Lightning can produce particulates in the atmosphere, wildfires, and different types of vegetation in terms of providing organic material and matter into the atmosphere. Then we have anthropogenic. Now, again, with environmental science, the focus is on the anthropogenic influence on our natural system, in this case, the atmosphere, and in this case, the increased concentration of particulate matter produced by human activities and human-based processes. For example, industrial processes and industrialization, the production of particulates through fossil fuel combustion, through cars, trucks, anything on the road, looking at energy production and biomass combustion, looking at transportation, like an aircraft with condensation trails and boats and cruise liners, looking at agriculture and livestock and having concentrated areas of urbanization, which is going to produce particulate matter in large concentrations. And finally, any kind of landfills and waste decomposition is going to produce particulate matter into the atmosphere as well. Now, anthropogenic is mostly focused and concentrated in the troposphere. The stratosphere is more to do with aerosols and mainly sulfuric acid in the aerosol mixture. We've established that particulate matter is tiny particles of solid and liquid. Now, if it's an aerosol, it would be a gaseous mixture with a tiny solid or liquid particle within that mixture. So in terms of size, what are we talking about? The unit is called a micron. UM is the abbreviation. The U in the unit for micron is actually a Greek letter, which is lowercase mu, and it basically represents the size. So basically means micro. And in physics, it can refer to friction, but in this case, is used in terms of population, in terms of size or number, which means micro. A micron is the same as a micrometer, or equivalent to 1/1,000,000th of a meter, or 0.001 millimeters. Now, it's very small. So you take a beach with sand, let's say yellow, golden sand, and you put your hand into that sand and take a handful of sand, and each sand grain is around 125 microns to 25 microns as a size range, or 0.125 millimeters to 0.25 millimeters. So very small, tiny. And this will be a fine grain sand. Now, particulate matter is defined really as a microscopic particle that is around 10 microns down to even 1 micron, or even smaller, half a micron. Now, 10 microns would be PM10, and this would be 0.01 millimeters, and that would be called a coarse particulate matter particle. Now, in terms of a smaller one, looking at 2.5 microns, or 0.0025 millimeters, or even smaller as PM1, which is 1 micron, which is 0.001 millimeters. So understanding how small these tiny particles are will help to relate to environmental issues, air pollution, smog, and any health issues that are incurred from breathing in this size of particle into your body. Particulate matter comes in two distinct classifications, PM10 and PM2.5. There's also a PM1.0, but it's not as commonly used as the other two size ranges. So PM10 is 10 microns, or 0.01 millimeters, or 10 micrometers, down to 2.5 microns, or micrometers. That is a certain size classification. So anything between 2.5 and 10 microns would fall under the PM10 classification. Then we have PM2.5, which is a much smaller particle, which is 0.0025 millimeters, and anything less than that will be classified under the PM2.5. Now, why do we have just two classifications for a large range of particulate sizes and different kinds of matter? Is because the effect it has on the health of humans, organic life forms, and also the environment. So PM10, the larger particle, examples are dust, smoke, pollen, mold spores, sea salt, industrial emissions, agricultural emissions, and certain gases and aerosols that are large enough to be in that PM10 classification. Whereas the PM2.5 particles are primarily the same type of particle, like dust, smoke, pollen, mold spores, sea salt. However, these are the smaller size version, the minute particles of these sources and types of particulate matter, and also organic matter. Bacteria is classified in that 2.5 range. Particulate matter can vary greatly in its concentration within the atmosphere, in particular the troposphere. Now, it can vary based on the sources, based on the environments, and based on atmospheric conditions, but the concentration is very important in regards to air pollution and air quality. The higher the concentration, the lower the air quality, and the more dangerous the air becomes if you are breathing this air in, or you're in an environment which is going to be affected by this particulate matter. So we know that it comes from both natural and anthropogenic sources, and the focus of the air pollution component of this video is the anthropogenic, the excess particulate matter which is produced and then flows into the atmosphere, and it's going to reside and stay in the atmosphere for a given time before it is removed through different sinks and deposition. So the concentration can vary. Obviously, it'd be greater over industrial areas, urbanized areas, cities, conurbations, and suburbs. And it can also vary based on the time of day and the season, latitude, location, and it would be reduced the further away you go from any natural source, like a volcano or an ocean or arid dry land, and also away from any human activity or populated area, which would increase the chance of any particulate matter being produced through the various anthropogenic sources. So far, we have established what particulate matter is by definition, the different sources and where it originates from, either natural or anthropogenic. The concentration levels vary based on environment and source and the amount of human activity and human population, and also the different size of particles that reside in the atmosphere, from PM10 being the largest, PM2.5, and occasionally PM1, which is ultra fine. So the particles themselves can stay in the atmosphere for a given time, which ranges from minutes up to days, and this is called residence time. Now, this is based on many factors, including the atmospheric conditions, for example, high pressure or low pressure, wind, humidity, precipitation rates, the density and mass of the particle, the source of the particle, type of the particle, and of course, gravity. Now, once the particulate matter has spent its time in the atmosphere, it is going to be removed through two different processes called deposition, and this is done either through dry deposition or wet deposition, and this would be a flux where you have the movement of the particles from the atmosphere onto the Earth's surface, and this would be deemed a sink, where that particulate matter would then stay on the Earth's surface for a much longer amount of time. To gather data and to establish how much particulate matter is in the air at a given time and a different location, and perhaps indicate and infer the source of the particulate matter or the chemical composition, you would use a gravimetric analysis, which is a common method to analyze the total mass of any particulates that are found in a given area through this piece of equipment, which basically is a bunch of filters which can be weighed before any particulate matter is exposed on the filter, and then weigh it after to get the concentration analysis of any particulate matter which is caught in the filter. Now this can be modified for both large, coarse PM10 particulates or finer 2.5 or ultra fine less than 2.5 or PM1. So this is a common method for scientists to establish the total mass and concentration of particulate matter in a given location at a given time, and allow scientists to produce accurate levels of particulate matter for air quality measurements and health considerations and alerts through various information portals. In addition to gravimetric analysis, you also can use optical particle counter, or an OPC, which basically is using light to count the particulate matter in the filter, and also use light to scatter when it encounters particulates, and this scattering can be calculated to figure out the mass of the PM that you have in your filter. So other methods are used, but the gravimetric analysis is the most common. Air quality is the measure of air pollution at a given time, a given location, and provides information to people and the public about the risk they are taking when exposed to a level of atmosphere which is deemed hazardous. Now, air quality is a wide range or continuum of air pollutants that combine in the atmosphere to create a certain level of quality. Now, if you're exposed to air with minimal air pollutants, the air is going to be of better quality, versus over an industrial factory urbanized area of a large city where you have many different air pollutants like NO2, SO2, CO, CO2, particulate matter, tropospheric ozone, all combined together in the atmosphere at a given location of a given time with given atmospheric conditions. The air quality will be significantly decreased and cause exponentially more harm to any humans exposed to this air, and also the environment, the animals. Humans are going to inhale any particles in the air, and based on the particles size, whether it's PM10, which is coarse, or smaller, PM2.5, or fine or ultrafine, PM1, you're going to have an increased risk of damaging your health when you breathe in these smaller fine and ultrafine particles, because they can go further into your body through the lungs, through the alveoli, through the bronchioles, and into the bloodstream itself. Particulate matter is classified into two distinct size ranges, PM10 and PM2.5. PM10 is obviously larger, and the particles are considered coarse, whereas PM2.5 and even smaller PM1 is considered fine and ultrafine. Now, why are these two separated based on size? Well, it's when these particles are inhaled by humans, the air containing particulate matter is going to enter the body, and PM10 will enter as far as the esophagus and trachea and will not enter the lungs, which means that the effect on humans is decreased. It still can be toxic, hazardous, and cause harm, but it's not as harmful as the smaller, finer, ultrafine particles of PM2.5 and PM1. These smaller particles are able to go straight into the lungs, through the alveoli, and into the bloodstream, causing increased harm to the human body. Again, this is based on the prolonged exposure, the concentration, and the type of particulates that are entering the body. But the main classification is down to the effect and how far these particles are going to go once they enter the human body. Once a human inhales particulate matter, it's based on the source, the size, the concentration, the length of time that the person is exposed to this poor air quality with high levels of particulate matter, and of course the individual's health. Now, the health could be fantastic, or it could have some predisposed or prior medical conditions that could be triggered or made worse by inhaling particulate matter. So acute health issues include the increased risk of asthma, either getting asthma or making your asthma worse if you already have it, acute bronchitis, which is more extreme, and the increased chance of respiratory infections. Again, the degree is based on the individual's health and the amount and concentration of particulate matter in the lungs. Of course, the size is critical because PM 2.5 and smaller, the fine and ultrafine, is going to reach the lungs and cause these kind of health issues. Then if you're exposed to particulate matter over a long period of time, again, that is based on the individual's reaction, concentration, location, then you get some chronic health effects, which include decreased lung function, chronic bronchitis, aggravated asthma, and unfortunately premature death in extreme cases. Particulate matter plays an important role in the air quality, the atmosphere in terms of the troposphere and stratosphere, the ecosystem health, human health, as discussed earlier, but also the climate system and the Earth's energy budget can and is affected by particulate matter. Now, the increased amount of PM and the influx of PM from anthropogenic sources plays a role in changing that energy budget and changing the chemistry of the atmosphere and how energy is absorbed, reflected, and utilized within the atmosphere, and also how it gets to the surface. So interference is a major part of what PM does in the troposphere and stratosphere in terms of reflecting back a lot of energy into space and also reflecting energy back towards the Earth as a greenhouse effect, which also relates to radiative forcing and the ability for the atmosphere and molecules to absorb energy and then re-emit the energy as infrared or heat back in the atmosphere and back towards the surface. Now, also looking at cloud formation, so condensation of water vapor occurs at a certain temperature and altitude and pressure called the LCL and the dew point, and this involves CCM, which is a tiny particle of material, so a particulate matter of different sizes, of different origins, like salt, like pollen, like sand grains. But if you have an influx of particulate matter, you're going to have an increase in cloud formation, which then would disrupt the energy going down to the surface and being radiated back to the surface, and you would change the temperature of the atmosphere as well with increased cloud cover and potential changes in precipitation rates and locations of precipitation, again affecting the surface like soil and river systems and ecology. And then we have the effect of particulate matter on the chemistry of the atmosphere and how the particulate matter can chemically combine with other gases in the atmosphere and also with other particulate matter to create secondary PM, which can then affect the atmosphere's chemistry and also add more interference and more radiative forcing and changes to the Earth's energy budget as it goes through the atmosphere. So all of these must be considered in the effect of adding increased amounts of particulate matter into both the troposphere and the stratosphere. In summary, particulate matter is microscopic particles of matter, usually solid matter, and it also comes in aerosol form, which is that solid particle surrounded and encapsulated by a gas. Now, this aerosol usually exists in the stratosphere, and the regular particulate matter, which is just the particles, would be more in the troposphere. Now, in terms of sources, it comes from both natural and anthropogenic, which includes different kind of terrains, like forests, oceans, soil types, and vegetation. And it also comes from various human activities in terms of urbanization, industrial areas, transportation, agriculture, and producing energy. Now, the atmosphere acts as a sink for particulate matter as it flows in from different sources, and it resides there for a short time and then is removed through different types of deposition, both wet and dry, and this includes both the troposphere and the stratosphere. In regards to the troposphere, we're looking at air quality and the amount and concentration and type of particulate matter in the atmosphere, whether it be PM10 or PM2.5, which is the classifications that separate the different sizes based on the effects on humans, which can be both internal in the mouth, trachea, esophagus, and also in the lungs and alveoli and bronchioles, and potentially into the bloodstream if the particulate matter is small enough, like PM2.5, or smaller PM1, which is ultrafine. And then finally, the effect on the climate system, the Earth's energy budget, the amount of reflected and absorbed energy in terms of radiative forcing, and the temperature of the atmosphere, and also cloud formation. This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth science, please check out my channel.